National Institute of Rock Mechanics. Can you just walk us through the journey? What is it?
Kolar Institute of Rock Mechanics, but later it was named as National Institute of Rock Mechanics.
What is rock mechanics?
I'll give you an example of Vidhan Soda station, where on one side you have Vidhan Soda, on the other side you have High Court, right?
History defining Ram Mandir project. Can you tell us the contribution of NIRM in the whole project? Sir?
Every rock is inspected by our experts and it is certified that it is defect free.
When the Addl was selected and he told us that it was tested by NIRM, it is a pretty proud moment for all of us who are associated with it.
Welcome to the first ever episode of Beneath the Surface, the official podcast series from the National Institute of Rock Mechanics. In this series, we go deep, quite literally, exploring the science, the stories, and the people shaping India's underground infrastructure, rock engineering innovations, and more. From tunnels and mines to dams and disaster resilience, we shine a light on what lies beneath. I'm your host, Abhiram, and today it's a true honor to begin our journey with a stalwart in the field, Dr. Sripad R. Naik, Director, Additional Charge, and Head of the Numerical Modeling Department at NIRM. With over 30 years of experience, Dr. Naik has been at the forefront of India's major infrastructure projects, driving research and technology in geotechnical instrumentation, slope stability, and advanced numerical modeling. In today's conversation, we will uncover how the science of rock behavior powers national development and why geomechanics is more critical than ever and what it takes to lead from the front in both engineering and institution building. So let's get started and dig into the world of rock mechanics with Dr. Sripad.
Sir, hearty welcome to the show.
Thank you.
So we are glad to host you. We are glad to have you here and glad for accepting our proposal to do the podcast.
Thank you, Abhiram.
So let's dive right in, sir. Let's dive right in. National Institute of Rock Mechanics. Can you just walk us through the journey? What is it? What is this institute all about? And how has it impacted India's growth story in the last 45-50 years?
It has got a very interesting history. You must have, almost everyone is aware of Kolar goldfields, where gold is mined for over 150 years,
Right.
To a depth of 3.5 kilometers.
Wow. Okay.
So when they were mining at that particular depth, there were a lot of strata control problems. In the sense, there used to be rock burst and other incidents. So that used to cause a lot of damage to the machinery as well as human lives also. A lot of lives were lost.
Right.
So the Bharat Gold Mines Limited, which was managing this particular gold mine, they had one rock mechanics wing.
Okay.
So they used to monitor all these activities, rock burst activities, and they developed a lot of rock mechanics instrumentation and rock mechanics techniques, seismic networks. So that was helping them in identifying these rock bursts well before it was occurring and recording these rock burst locations. So this was quite a lot of trained people were there in that particular department. But later, when the mining activity was getting almost a closure, it was coming to a closure, then Ministry of Mines, Government of India, they decided to make use of that rock mechanics facility and to make it a national laboratory, so that the experience and the infrastructure that was there, that will be used by all the mining companies. That was the original objective.
Wonderful.
So they made that particular facility into a national lab. And initially it was named Kolar Institute of Rock Mechanics, but later it was named as National Institute of Rock Mechanics, and it was established in 1988. And That time, Mr. B.K. Rao, he was a secretary of mines. He was instrumental in creating this facility, and that's how we started our journey from Kolar Goldfields.
Amazing. So, for our listeners who are beginners like me,
Yeah.
what is rock mechanics?
Yeah. See, rock mechanics, it's truly an interdisciplinary subject. It's a mechanics that deals with, you study the any changes that are taking place once you disturb the rock, or when you create a structure inside the rock mass. So, how the rock is going to behave. So, the study of behavior of the rock mass and the structures that you created. So, that is called rock mechanics. So, basically, you are making use of the principles of mechanics only, but that is extended to rock. As you are aware, this is quite different from your civil engineering structures or anything, because in civil engineering structures, the loads that are coming on to your structure. Accordingly, you design the elements, and then you select the material, right?
Correct.
Suppose maybe it is a building, so you first design the beams, columns, your foundation designs, everything you design, and then later you select what is the concrete makes, or how much steel is required. It's all calculated later.
Correct.
But in case of rock mechanics, you are creating a structure within the rock, right? So either within the rock, in the sense, you are creating a tunnel. Okay, before you create a tunnel, it will be in a state of equilibrium, right? It is not disturbed.
Correct.
Because it is in the mother earth, so it is not disturbed. The moment you create a tunnel, the surrounding rock mass is getting disturbed. So the initial forces or stresses that are there inside the rock mass, that will get redistributed, right? Because it has to get back to one more state of equilibrium, so that it will be stable, right? So we have to study. So what happens when you create a tunnel inside a rock mass, which was otherwise stable, right? But
Correct.
because you are creating a tunnel here, so the state of rock mass is disturbed.
Correct.
So we have to understand how that is going to be redistributed. The stresses are going to be redistributed, and you are able to create a stable tunnel inside the rock mass.
Right.
And in rock is such a thing that you don't get a stable rock mass or a competent rock mass everywhere. So if you go to Himalayas, the quality of rock, because they are very young rock, so they are not stabilized yet. So it is a very complex kind of rock.
So sorry to interject here. What is the concept of young rock?
Yeah, young rock. Because geology, if you go back to the geology, geologists talk in terms of millions of years only.
Right.
Because what happened was the rock that are there in Himalayas, initially they say that there also it was sea only. Then later it got all the this
continental drift happened.
Yes.
Right.
And because of that, there will be submergence of forest, and then deposition takes place gradually, right? So because of that, so it takes millions of years to get that consolidation, because it will be under a lot of pressure and temperature. So it will take millions of years to get the consolidation phase. So the rock that we see in Himalayas, they are relatively young in nature. Compared to the rock in down south, it is called Deccan Trap. Yeah. So there we have a very stable rock. So if you the tunnels that are created in Deccan Trap are less likely to have problems when you make a tunnel. Whereas in Himalayas, you are most likely to have problems when you are driving a tunnel. So our job as a rock mechanics engineers is to understand the behavior of the rock mass here as well as elsewhere.
Okay.
I mean, under different geological conditions.
Understood.
Yeah.
Sir, we spoke about rock mechanics in detail, and we've all heard about geology. How different is rock mechanics from geology? When you said interdisciplinary, subject, what exactly do you mean?
Yeah. See, mechanics is generally, it is the study of the interaction of different forces on the body.
Right.
But rock mechanics, see, it is truly an interdisciplinary subject, in the sense it involves the interaction of like, it is a mix of like soil mechanics, geology, geophysics. Because see, the rock is subjected to because rock is there, like we are dealing with geology, right? So all the because you will not find uniform geology anywhere. That's what I already told you about that. And there will be a lot of geological disturbances, like in the form of joints, shears. So you need to have a thorough knowledge about geology, right? Because we are creating a structure inside these geological features. So we need to understand how it behaves, how those features affect our structure, like our tunnels or a caverns or a mine, because they are going to be disturbed, right? The original joints or shear zones, whatever was there, that is getting disturbed when you create an excavation. So we need to understand how those features are going to have an impact on your structure. So that is important. So geology is part of the understanding of geology is very, very crucial for rock mechanics. And then understand geophysics. Geophysics also is very, very closely associated with rock mechanics, because geophysics is a set of like techniques for understanding the rock mass without like it is a non-destructive testing sort of thing. Like we don't disturb the rock mass to understand the nature of the rock mass. So using geophysics, we can understand some of the hidden structures. So that will help in our rock mechanics analysis. So we can incorporate all those structures that was associated or that we get from geophysics. So rock mechanics is an interdisciplinary subject where it utilizes the expertise of geology, geophysics, and of course the mechanics understanding the principles of rock mechanics, and it also like we have to make use of the power of computers also. So we have to analysis we have to make use of analysis. So for that we make use of numerical models, right?
It is a discipline that you had.
Yes.
Right. So can you just briefly tell us what is numerical modeling, sir?
See, numerical modeling, it's like we are making use of the computing power and the principles of mechanics and the actual problem that we deal with, right? So to put it in simple terms, structures that are created in tunnels or caverns, or they are not regular structures. Like you don't get a circular structure like that. Either it will be D-shaped, or there will be many like even in mining, the geometry of the structures, they differ. Okay, so we cannot use. See, there are techniques, analytical techniques for analysis of. Suppose if you have a circular tunnel, okay, then when you make a circular tunnel, what is going on in the periphery of the tunnel, that we can analyze using analytical technique, because there are set of equations, right? So we can simply put that equation in an Excel sheet or something, we can get the information.
Agreed.
But here we don't have a regular structure, like either it will be D-shaped, or if you have seen some of the stations in metros, they are like very huge structures where there is it is not like a uniform structure. Like it will be very long, and there will be like sloping structures.
Topology will change.
Yeah. So you cannot study the behavior of such structure using analytical methods.
Okay.
So for that we make use of a numerical method.
Mm.
To give you a simple analogy of a numerical method, instead of 2, I will make it as 1.999.
Mm.
Okay, or I will make it as 2.0001.
Mm.
So both are acceptable to me. They are not much different from 2. So it is acceptable. Like for practical purpose, I can take it. Even 1.999 also, I can take it as a value which is very close to 2.
Correct.
So I'm not making any major mistake in that. So when we use the numerical model, you don't get exact solutions.
Mm.
Okay, you will get an
Approximate
approximate solutions. So we can make use of that. So what we do is here, see, we don't have a regular structure like a circular or a square structure, right? So what we do is, whatever structure we have, we subdivided it to small structures. Okay, suppose a big this one tunnel is there, that one, it's of irregular shape. I will divide that space into small triangles or squares. So, and then I will make it a whole assembly, I will make it. Okay, so these interaction of these small structures, it will go on like, I will, instead of analyzing the whole thing, I will analyze part by part, then assemble it together.
Correct.
Okay, so I will be able to digitize my entire space outside the tunnel also, and get a solution at every point.
Amazing.
Using the analytical, like whatever the equations are there. Okay. So that one, there are methods, like there are finite element methods, there are boundary elements method, and these are for, there is what is called continuum methods. Continuum methods in the sense, the space where my tunnel is there, I am assuming that there are no geological structures. Right. There are no joints, or there are no shear zones or any structure. Whole thing is a continuum. Except my tunnel, there are nothing. Only the rock mass is there, and it's a continuous structure. So that is continuum models. So we make some assumptions in that. Okay. But in some cases, we cannot go with such assumptions. Okay. Because you have a tunnel, but there are joints or shear planes that are influencing the behavior of your cavern. Okay. So you cannot ignore them and do an analysis. For that, we have what is known as a discontinuum model, where we will be able to model all these joints and other geological structure also. We will model that also. Understood. We will model the behavior of those structures also. Understood. So this will be more realistic in the sense, so we can take the actual geological structures as we encounter in the field, and then we make the analysis. But there is you have to go very cautiously here, because whatever model you are doing it, so you have to take the input parameters. That is you are going to input to the model, right? So it may be in the form of, you need in situ stresses, because as I told you earlier, here we are creating a structure which is already stressed, because rock mass, that is Mother Earth, it is already stressed. In situ stress is already there. Right. So you are creating a tunnel here. So that for stress redistribution to take place, we should also know the original stress that is present in the ground. So that is a very important parameter, that is in situ stress. And then the properties of the rock mass. See how stiff or how soft that rock mass is. Okay, for that we have to conduct laboratory tests or some in situ tests to know the strength of the rock mass. So that also goes as an input to all these models. Okay, and then we should know the geometry also, and then inclination or orientation of the geological features. So all these goes as an input to the numerical model. Okay. And what we get output we get in the form of how much displacement is going to take place, like how the tunnel is going to deform. Right. See, original tunnel, whether it is going to be safe or whether it is going to collapse. All these things we can analyze in the model itself. Amazing. Okay. And advantage of these models are, see, you cannot go on experimenting all these possibilities in real sense, right? In the real ground. So it takes a lot of time and a lot of resources. But here in the model, we can change the parameters. Like I can change the dimension of my tunnel.
Right.
Or I can change the orientation of the tunnel. Okay, sometimes just by changing the orientation, just by shifting the alignment of the tunnel little bit, just by 10 degrees, 15 degrees, you will get a stable tunnel.
Amazing.
So that is the advantage of carrying out all these numerical models. So you can run hundreds of models and come out with an optimum solution. Yeah, that is it. And you cannot simply go by the output of these numerical model. You also have to calibrate the model. I mean calibration in the sense, whatever you have done, whether it is going to be happening in the ground also, same thing, whether same thing is happening or not.
Right.
So how do you confirm? For that, we have to instrument the tunnel. Okay, we have to measure. See, suppose you have done a model and that tunnel is being excavated. Okay, you put some instrument and measure how much deformation is taking place, or put some stress cells. So you know how much change in stress is taking place in the rock mass.
Understood.
Okay.
Yeah.
Same thing you can compare it with your model, whether your model is also giving an same solution or not. So then you can calibrate the tunnel. Then with that calibrated model, you can use it in the same area, somewhere else in the with the similar properties or similar setup you want to carry out the tunneling. You can use your model and you can suggest a very good design can come up with that.
So fantastic explanation. It was very, very informative personally for me, because I always wondered the kind of effort that would take to construct something like an the Addl tunnel.
Yes.
Yeah.
Yes.
I'm sure NIRM had a hand in it as well.
That is in
Jammu.
Jammu. Yeah. We did some testing, but we were not actually involved in the construction of the tunnel.
Understood. Yeah. But I would always think what it would take for something like an Addl tunnel to get built.
Yes.
You kept saying that, Himalaya is a young rock.
Yeah. Exactly.
And even the tunnels that are constructed elsewhere, I think the concept of stress redistribution was very enlightening personally for me.
Yeah.
From the NIRM standpoint, sir, can you briefly tell us what are the different departments that come under NIRM, and how are these departments value adding to NIRM in that sense?
Yeah. As I told you in the beginning, rock mechanics is an interdisciplinary subject. And see, whenever you want to create a structure inside the rock mass, first you need to characterize the rock.
Right.
So we have departments that takes care of site characterization. That means before you construct a tunnel or a cavern or any structure, you have to characterize the site. Right. So that is site characterization. So we have departments to deal with that. And then we have, once you characterize the rock, then we have departments for design of the tunnels or cavern or for the analysis. Okay. So design phase. And then during the construction also, we have departments to take care of that. Okay. So to start with the site characterization departments, where we need to understand the site. Okay. For that, see, first one is we have a testing laboratory that is of ISRM, like it's an international standard testing lab we have, where we carry out all the tests related to rock mechanics with ISRM standards. There is a International Society for Rock Mechanics, ISRM.
Okay.
So they have a set of standards.
Okay.
So we need to adhere to that standards, and we have almost all these tests coming under that standards. And so what we do is, so the samples from the site are taken. See, the borehole samples are taken, and we prepare the samples, and we carry out like uniaxial compression strength, tensile strength, and triaxial strength. There are so many other tests that we do it. And so we do all the testing requirement that is needed to characterize the rock. So once you know these values, that will give you an idea about whether the rock is sound, or whether it is competent or not. So that is the first phase. And then we have that is testing laboratory. We have a testing laboratory at Kolar Goldfields. Actually, I forgot to mention, we have two offices. One, our registered office is at Kolar Goldfields. In fact, it was started from there only. And from 2008 onwards, we started our office in Bangalore also.
Right.
And now coming to the site characterization thing, we have engineering geology department. Okay, so what they do is they will based on the borehole data and depending on the site visits also, they will inspect the site and see the geological structures and identify are there any structures that are going to have a influence on the tunnels or a caverns or any structure you are going to build. So they will analyze that one, and they will also characterize the rock mass. There are rock mass classification systems.
Right.
So that will identify whether rock is good, bad, or ugly. So it will have a scale from 0 to 100 sort of thing.
Okay.
So that will it is known as there are various schemes are there. So rock mass rating, Q rating, GSI rating. So they will collect different parameters will be there. So they will give weightages to different parameters, and then they will arrive at a parameter.
Got it.
So for anybody, when you say RMR of 50 or 80, so they will immediately understand whether the rock mass is competent or not.
Okay.
So that is the role of our engineering geology people. So they will characterize the rock. And then we have a geophysics department.
Okay.
So geophysics, as I told you, it's a non-destructive testing sort of thing. So what they do is, using the principles of geophysics, they will analyze what is there below the earth or behind a tunnel.
Okay.
So that they will give you a complete, it is just like an MRI or X-ray of the ground.
Okay.
Yeah. So it is just, it will give you a complete picture. So we have all the state-of-the-art equipment in our geophysics department. So they will carry out all these tests. There are like seismic tomography, then GPR. There are so many other techniques. So they will use all these techniques and they will characterize, they will come up with study. Like, for example, we carried out because Southern Railway, they wanted to have an alternate tunnel. Tunnels were already existing. By the side of the tunnel, because they were going for the doubling of the track, they wanted to do separate tunneling. So because it is an inhabited area and it is very difficult to do sometimes drilling also there. So there we adopted this geophysical techniques.
Okay.
Because it can give you a complete picture whether where is the soil, whether there is a rock, at what depth rock is coming up, or there are any water. Water is this one, and it will give you some idea about the strengths of the rock also. There are geophysical methods. So we use these geophysical method again to characterize the rock. It will give you an idea about, before going for a tunneling or any operation, it will give you a fair idea about what is there beneath the ground. Before
at any point in this, do you also use satellite data, sir? Is that also available to you, or is it, you have your own
because satellite data, it will give you like surfacial information only. It cannot give you, it is used for mineral exploration and other things, but it will not give you in detail information. If it is required, then you have to go for
so it's all your equipment that you use.
Yes.
Okay.
So that is geophysics department. Then we have engineering seismology also. Engineering seismology, they will study the seismic behavior of like whether that particular area is seismically active or not. So they can also like set up the seismic networks to understand this one. And they can also study the micro seismicity of the area. That means at a very micro level, they can study the behavior of the rock. So that also we have. That is also used during post-construction, this one also, to monitor the tunnel also. So that department also we have. And then coming to the design stage, we have numerical modeling department is there, where we do all these design studies, as well as we also do this using this instrumentation data. We also analyze the stability of the structure also.
Okay.
And then coming to, and one more department in this one I forgot, geotechnical engineering department. I was talking to you about in situ stress measurement and other things. So it is very important to understand the status of the stress that is there within the rock mass before you go for excavation, right?
Understood.
Because it is particularly important in the case of all these large caverns are constructed, particularly in the Himalayas and other elsewhere in India also. So they are huge structures, not like simple tunnels. See, caverns, they it is like sometimes it is of the size of a football ground, like
Understood.
so 200, 300 meters long, 20, 30 meters wide, and it is not one single caverns. There will be multiple caverns also.
Correct.
Because you need to house all these equipment for electricity generation. Correct. Or even for storage of oil storage, and
Correct.
nowadays even for food storage. All these things are coming up, caverns.
Correct.
So they are sometimes seated deep underground. So we need to understand the status of the stress, right? So we have a department, geotechnical engineering department, where we can measure the in situ stress, and we also measure the deformability characteristics underground. Okay. Similar to what we do in laboratory, there are tests that we can do it at the site. At the site and get the real feel of the ground. So there are parameters like deformation parameters. So that also we have that department. In site characterization, we have one more important department, that is seismotectonics department.
Okay.
See, you must have heard about these nuclear power sites. Nuclear reactors are being established for power generation and these ones. So these, the requirement, the site requirement, they are very stringent for establishing these nuclear reactors and other things, because these sites should be free from any geological structures. Like they should not be it should not be there in earthquake prone this one, or there should not be any major lineaments or any major fault zones or such kind of structures. So that will have an impact on these, because they are very sensitive structures.
Absolutely. We saw it in Fukushima. Japanese, exactly. When tsunami happened, it caused this massive radiation outburst.
So, because of that, the requirements are very stringent. So for that, we have a seismotectonics department. So they will carry out elaborate geological studies. They will make some trenches in the proposed areas. So large area they cover, and they use satellite images also to identify any lineaments or fault zones. So first they will use the satellite images and very high resolution satellite images, and they will identify the likelihood of any presence of any hidden faults or all these things they identify, and they will assess the possible seismic event that can take place, whether it is a safe zone or not. So we carry out all such studies. That is seismotectonics department. And coming to during the excavation stage, when you need to excavate a tunnel in a very fragile environment, or suppose you are driving a tunnel beneath the inhabited area, okay, or near to some structures. So we have to carry out we have to excavate it very carefully. Otherwise, So it may create unstable structures, means it will impact the structures above the tunnels also. Okay, it
Correct.
may collapse, or it may create some sort of disturbances to the structures also, like it may create some cracks. I'm giving you an example. See, during the construction of these metro tunnels, particularly for excavation of your station areas, right? Station
It is
areas, I'll
underground
give you,
station
yeah,
area.
underground
Yeah.
station. I'll give you an example of Vidhan Saudha station,
Mm.
where on one side you have Vidhan Saudha, on the other side you have High Court,
High Court.
right? So in between you need to excavate. That is, as you know, Bangalore is a granitic terrain. It's a very hard rock. So you have to, because see, tunneling you can do it with tunnel boring machines, but what about the station areas? Because you need a huge area. You
Huge
cannot
area.
excavate with TBMs. So you have to go for drilling and blasting.
Mm.
So drilling and blasting, if it is, because it's a hard rock, if you don't do a controlled blasting, then it will damage your structures nearby, the foundations of your Vidhan Saudha or High Court, because important historic structures are there. So there you have to control the vibrations that is created from your blasting.
Fantastic.
So you have to plan a controlled blasting, this one. So we have that expertise at NIRM. We
Mm.
have a team, rock blasting and excavation engineering department,
Mm.
where we carry out these control blasting near any structure, be at, it may be, so we have done it in near to an operating airport,
Mm.
like in Chennai airport, this one. So the new terminal that has come up now. So there some blasting was required. So our team has carried out the blasting.
Amazing.
And most of the metros work, because all these metros are driven in a populated
Correct.
area. Yeah. So there you have the structures on the surface, and you need to very carefully you have to blast this one. And there are some restrictions on vibrations also. Vibrations cannot exceed certain limits. So we have to restrict the vibration caused by this blasting to that limit. So we have the design capabilities and all the equipment also we have in our lab.
That leads me to the next question, sir.
Yeah.
Talk us through some of the crown projects that you have handled, so that our audience know the kind of impact has NIRM created in the society.
Yes. To start with, the NIRM started with an objective of meeting the requirements of metal mining industries. Slowly, we expanded our activities into coal mining. We have done a lot of projects in Singareni coal fields and some of the Coal India projects also. And later we have expanded, because rock mechanics is just not limited to mining, coal mining or metal mining, because infrastructure projects, hydroelectric projects, nuclear projects, all these areas also they need the rock mechanics interventions. So we have done for major hydroelectric projects in the country, and even in our neighboring countries of Bhutan and Nepal, we have carried out a lot of studies, and we have helped in commissioning of those projects.
Amazing.
Yeah, some of the projects like the important projects, particularly in the hydroelectric sectors, you must have heard about the Natpa Chakri project.
Right.
That is one of the biggest hydroelectric project in India.
Correct. Talk us through some of the crown projects that you have handled.
So there a big cavern was excavated to house all these electrical equipment. So we have we did a lot of instrumentation, numerical modeling, geophysics studies. So all this helped them in safely excavating those caverns and ensuring the stability of those caverns. So that we have made sure. And then Teri project we were associated with. And then Sardar Sarovar project, which is a very prestigious project.
Correct.
We are associated now also. We are continuing the monitoring of the instruments that are in the powerhouse cavern, and the dam also we are monitoring. And we like in our neighboring countries, we have done in Bhutan, we have done a lot of projects. Two major hydroelectric projects. One was Tala hydroelectric projects. There we have from almost all departments, we were associated with that particular project, right from the 3D numerical modeling and instrumentation. This was one of the biggest instrumentation project in hydroelectric sectors.
Okay.
Like that helped them in monitoring those huge caverns. Particularly, that was a very problematic cavern, in the sense a lot of falls and other things had taken place in the initial stages. So, and then our blasting team was also involved in control blasting, so that the excavation was carried out very smoothly and the cavern was stable. And we carried out that instrumentation studies for almost 20 years. So that is,
okay.
Yeah. So now we have got data for almost 20 years. That is very rare in any hydroelectric project.
20 years is a huge time.
Yes, yes. And recently we have done one more project in hydroelectric project in Bhutan, that is Punasangcho hydroelectric project. There also a lot of these strata control issues and rock mechanics related issues were there. There also our instrumentation team, then our control blasting team. So we were involved in that. And now that cavern is safely excavated, because it was there was a huge fall of the cavern, and it has to be sort of reconstructed, not exactly reconstructed, like a lot of changes were there in the caverns and some remedial measures have to be implemented. So there we assisted them in 3D modeling and control blasting and all these areas. And now the project is commissioned. So we take a very pride in
absolutely.
In those things.
Amazing. So some of the metro projects that you are associated with.
Yes.
Bangalore Metro.
Bangalore Metro, in particularly in blasting, and in Chennai Metro and Mumbai also. Mumbai Metro also we are associated with that.
Okay.
And some of the even some of the airports where this one, and so near to some of the dams also, existing dams also, our people have carried out control blasting and they have helped them, that one.
Amazing. So one of the most prestigious project that NIRM is associated with is history defining Ram Mandir project. Can you tell us the contribution of NIRM in the whole project, sir?
Yes. Ram Mandir project, it's a very prestigious project, and it is a proud moment for us also. As you are aware, Ram Mandir is designed for more than 1,000 years, and best of the best rock needs to be there. It is. I'm not talking about only the idol, Ram idol. It is about the structure also.
That was a common conception, sir, because Arun Yogiraj spoke about the. So it's not just the Murat, it's also the.
It is also the all the rock that is used in the foundation and the superstructures. Every rock is inspected by our experts, and it is certified that it is defect free. So we have got the techniques to identify the rock.
Okay.
And we have tested all the strength of those rocks in our laboratories also, and make sure that the quality rock goes into the Ram Mandir, either foundation or the superstructure or. So there we analyze, our team analyze each, and they will examine each and every block that is put into Ram Mandir and certify. And they also visit, they will identify the place where from this source of this particular this one, they will go to the quarry and identify these whether it is suitable for this construction or not.
Amazing.
So that is we are very proud of our contribution in this particular prestigious project of our nation.
Amazing, sir. Absolutely amazing. We were thrilled personally now that we are associated with NIRM for some time. When Arun Yogiraj spoke about, I did not know the entire scope of work that NIRM has executed, but when the idol was selected and he told us that it was tested by NIRM, it was a pretty proud moment for all of us who are associated with NIRM.
Yes.
Sir, AI has arrived in a very, very big way. We know for sure that it is disrupting every department, every field, every vertical. What do you think is the impact of AI for NIRM or the rock mechanics study? Do you think it is conducive? Do you think it is going to value add?
Uh, my opinion is that it is not going to disrupt our whatever we are doing. We can only make use of, we can leverage the advantage of AI in our studies. So that will definitely help, because we collect a lot of data, and
Right.
so sometimes manually analyzing all those data, so that requires a lot of time. So definitely in coming days, we are very sure that we will be able to make use of AI into our studies, definitely.
Fantastic. For an aspiring uh, NIRM, what do I call it? Engineer, right? Or a scientist. What is a good entry point to get into NIRM?
The basic requirement is either a mining graduate, or a civil engineering graduate, or a postgraduate in science. Either it may be geology or geophysics, and some electronics engineers also we have, because we do with a lot of instrumentation,
Correct.
these things also. So these are the main areas where people with all these background, they fit into the rock mechanics field.
Fantastic. How proactive has the central government been, and especially the Ministry of Mines under which NIRM comes? Can you just briefly walk us through their proactive contributions? Sir?
Yeah. The central government has very ambitious plans for various sectors, like it may be the port development, airport development, metros, and nuclear sites, and interlinking of rivers. These are, and any major infrastructure projects. So where the requirement of excavation and this one requirement is huge, and NIRM has got major role to play, and particularly our ministry, it's Ministry of Mines. The current minister, Mr. Kishan Reddy, and our Secretary of Mines, Mr. Kanta Rao, they are very supportive, and they are giving lot of encouragement to NIRM. So they want to develop NIRM as a center of excellence, so that NIRM is able to meet the requirements of the industry, so that will help the industry also.
That's fantastic to know, sir. That's fantastic to know. So fantastic talking to you. It was a great podcast. Thank you for sparing this time. We have learned so much. Our audience has learned so much about NIRM, so much about the contribution of NIRM in rebuilding the 21st century India. Thank you for your time, sir.
Thank you, Abhiram. I also enjoyed talking to you. Thank you.
Pleasure is all mine, sir.
Thank you.
So that was our first podcast produced by National Institute of Rock Mechanics. We'll be talking to more department head, more scientists, and we are going to get you a lot of content from NIRM. Stay tuned.